For this podcast, I'm going to go over explicitly how to predict products given only reactants in a chemical equation. So before we can even discuss some of the examples and going over it, these are the things you definitely need to know. So name and balance ionic compounds, name and balance covalent compounds, name and balance acids, know the diatomics, know how to balance equations, and know the different types of chemical reactions. So the best way to kind of tackle this is to go by example. So in this example, I have two compounds. So the first compound is sodium hydroxide, and the second compound is hydrochloric acid. So what's going to happen, I can immediately tell that this is a double replacement. I have two partners and they're going to switch. So basically the sodium and the sodium hydroxide are going to break apart, and the H and the Cl will break apart, and they will reform with their new partners on the right side. So I have Na here, and when you do this, you always have to reform them from the scratch. So Na is a +1, and then you have Cl is a -1. Oh man, that's really bad. Plus, well, now I got H, which is a +1 charge, and OH is a -1, so that balances. So after I reform these bonds, I have to double check that each compound is balanced. In this very easy example, they are. Sodium is a +1, chlorine is a -1, hydrogen is a +1, and hydroxide is a -1. So very simple to balance. So the products have now reformed. Now I got to balance the entire equation. So if you notice, it's already completely balanced. I don't have to put anything on here at all. So this was a pretty easy example to kind of see. Some of the key things to remember is you're breaking bonds here and you're forming bonds here, and you have to rebalance each one before you can balance the entire equation. So let's do a little harder one. Oops. Alright, so here we have a little more challenging one. So for this one, we have calcium acetate. It's reacting with potassium bromide. So again, the first thing you want to know is what type of reaction is this? And this is definitely a double replacement reaction. So we're going to be breaking bonds and reforming bonds. So the calcium and acetate will break apart, and the potassium and the bromide will break apart. Remember, positive only replaces positive. So the calcium is going to get together with the Br. So calcium is a +2, and Br is a -1. Now this is not balanced, so since calcium is a +2, bromine is a -1, I'm going to need two bromines, and that is now balanced. Next, I got to combine the potassium with the acetate. So, find my pen. So I'll have plus. Hope I have enough space. I'll write it down here. So I have potassium, which is a +1, and I have acetate, which is C2H3O2, and that's a -1. So those two cancel each other out, so this compound is now balanced. Alright, so since they're both balanced, each one is already balanced, I can now balance the entire equation. I have two acetates here, and I have one acetate here, so that means I should put a 2 there to balance out the acetates. I now have two potassiums, but I only have one potassium on the left, so I'm going to put a 2 there, and that gives me two bromines, and I got two bromines, so now that is a balanced chemical equation. So let's do another example. Alright, so this is not a double replacement. Here I have a single element. Let me change up the color. Here I have a single element, and then I have a compound. So this is definitely a single replacement. The aluminum is going to kick out the copper out to make it by itself. So copper will be by itself, that loner. And now the aluminum will now bond with the chlorine. So aluminum, the home wrecker, comes in. Aluminum is a +3. Chlorine is a -1. To balance this out, I'm going to need 3 chlorines. And that is now balanced. And when I say balanced, I just mean this. Copper is now balanced. It's a single element. So now each one is balanced. Now I have to balance the entire thing. And if you notice, I have chlorine, 3 chlorines on the right and 2 chlorines on the left. I can already know that it's going to be a lowest common denominator of 6. So I'm going to put now let's change the color just for the sake of trying some other color. I'm going to put a 2 right there and a 3 here. Oh, that's backwards. So that means I have 6 chlorines on the left and 6 chlorines on the right. That's good. I have 2 aluminums, so that means I have to put 2 aluminums there. So those are balanced. Now I got 3 coppers, so I got to put a 3 right there, and that is now a balanced chemical equation. Okay, one more example. Let me clear this up. So here we have CH4 and O2. This is an example of This is an example of combustion, and in combustion we always have the 2 products, which is always going to be CO2 and water. So if you remember your combustion reactions, these are always going to be the products when you see some sort of CH or CHO compound reacting with oxygen. Well, since the products will always be CO2 and water, now we can balance. I got 1 carbon there, 1 carbon, 4 hydrogens here. I'm going to have to put a 2 there to balance out my hydrogens. So now that's balanced. But now I got 2 oxygens plus the 2 oxygens, that's 4. I'm going to need to put a 2 right there to balance that out. And that is now a balanced chemical equation. So it's important to know your different types of reactions, and it makes this really easy. The last slide. Now, it's doing decomposition and synthesis ones are tough. And I'm not going to go over too many examples. I will tell you, you need to know these type of decomposition reactions. These are the ones that are kind of stressed by AP. So I'm not going to really test you on these other than the ones that you see here. So to stress, H2CO3, whenever you see this, for whatever reason, it always breaks down into carbon dioxide and water. So that's an important one. HC2O3 breaks down to carbon dioxide and water. H2SO3, which is sulfurous acid, that always breaks down into SO2 and water. And whenever you see HNO2, that always breaks down into these 3. Always. So, again, decomposition and synthesis are hard ones. There's just a few that you have to know, and these are the ones you have to know. Alright, I hope this helps.